Good morning, ladies and gentlemen. So today I'm going to be cutting this emerald. As you can see, it's got a little Pac-Man bite out of it, but that's okay. I'm going to fix it up and sell it. But that's not what I'm going to talk to you guys about today. Today I'm going to talk about how to dop a gemstone. This is going to be a little controversial because I'm going to say a lot of stuff that you all aren't going to like to hear, and I don't really care. I'm going to stick to my guns and talk about the science of dopping a gemstone. I've been wanting to do this video for a long time. Here we go. So I'm going to talk about the science, and I'm going to explain all of the technique that I'm using as well. And you can either agree with it or disagree with it. I really don't care. But we're going to go through it, and I'm going to show you how this works. So let's first of all talk about your starting point, and that is you have two starting points. One is the stone, like this emerald, and the second starting point is the dop. So this is an aluminum dop. These are actually terrible to use, and I'll tell you why. Aluminum is really actually flexible, and I mean that's why they make airplanes out of it, because it's light and flexible and cheap. You know, on an airplane, the wings flex so much when it gets the weight from the fuselage and the passengers transfused out to the wings. So those wings flex a whole lot, and that's because of the aluminum. Now, these flex a whole lot too, even though on a small scale, but you know what? Everything we do as gem cutters is on a small scale. So another thing with these, the second reason these are a bad idea, is they like to transfer heat really quickly. So that goes both directions. They get really hot really quick, and they get really cool really quick. And that's actually not ideal for dopping a gemstone using black wax. So this is the only wax I actually ever use. I do not use, and actually this is how I dop every gemstone, to be honest with you, almost every gemstone. But I don't use epoxy or super glue at all. In fact, I don't even have any. So I'm going to show you guys the best ways to use this. But first I want to tell you why you should not use epoxy or super glue. There's three reasons why you shouldn't use those materials to dop a gemstone. Number one, just like the aluminum dop, epoxies and super glues flex. They're designed to flex. They're made in a lab, and that's their job. They have specific tolerances for what they can handle as far as heat and lack of heat, and also how much flex they're supposed to have. Now, I don't care what kind of super glue or epoxy you use, if it's the stuff used on the Hubble Space Telescope down to the cheapest Elmer's glue you can get at Walmart. I don't really care. The point is that all those adhesives flex, and they're designed to do so. So again, just like the aluminum dop, bad idea. Number two, the second reason why I don't use those materials to dop a gemstone is it takes forever. Even the 5-minute super glues or whatever, that's too long for me. I don't have that much time. I cut a ton of material. That's my job. I'm a professional cutter, and I don't have that time. I don't get paid to wait for glue to dry or set up. I also don't get paid to watch it sit in acetone and trying to get it soak off. So that's the second reason I don't use those materials. The third reason is it's actually rather exceptionally toxic. Not only the super glue and the epoxy, but also the acetone or the attack or whatever kind of solvent you're using to get rid of that. It's really toxic to not only you, but also the stone. And I'll explain all this right now. So whenever you get super glue or epoxy or acetone on your hands, it absorbs into your skin. I know you're not thinking about it when you're doing it, but it does. Now here's the problem. You know, the chemicals that are in there, it's a really long molecule, and your body can't process it. So you store that in your body. It actually stores in your kidney and in your liver, and you never really get rid of it. So that's a bad thing. Acetone's the same way. You keep that in your body and it absorbs into your skin. So it's toxic for you. Secondly, it's toxic for the stone. And what I mean by that is, if you look at this emerald right here, you can see it's kind of got some inclusions, and it's got some little surface reaching fractures, and that's very normal for emeralds. But when you use super glue or epoxy and you're soaking it off to cross dop it or to dop it the first time, and you're using one of those kind of adhesives, what happens is when you're soaking that off in the acetone, it actually makes a solution. So now you have glue and acetone, mixed up in your jar that you're trying to soak the stone up, and the stone is submerged in it. Well, those fractures, and this could be an emerald, a tourmaline, or really anything, that has lots of fractures in it. What happens is that solution seeps into those cracks and then it dries out. Well, what happened now? With this emerald, if I were to use super glue or epoxy, I would actually be fracture filling this emerald. I'm not trying to, that's not my goal, but that is the case. And when they actually check for emeralds specifically, for being oiled or enhanced or clarity enhanced or whatever, they can find parts per million. So even just a little bit of glue in a fracture, boom, ruins the value, especially on like really high-end valuable stuff. So this one is not necessarily all that high-end valuable, but still, it's not, you can go stone by stone, but really it's just a procedural thing. So this is a really long video, so I want to get going and actually show you guys how this all works, but I do want to explain to you every little aspect and every little piece that I'm working on and the information so that you guys can kind of see the full picture. So when I actually dop a gemstone, and I'm not explaining what I'm doing, it takes me about a minute. Same with cross dopping. Dop, super fast. But it's all a technique thing and a little bit of science. So here we go. So alcohol flame, no big deal. Next thing, instead, I told you I don't use aluminum, I use brass. This is a much better dop stick. The reason for it is it's not as nearly as flexible as what aluminum is, and also it takes heat in and it releases heat, but it does it much slower. And I'll explain, that is very important. I'll show you why. So when I dop a gemstone, what I do is I put this in just a stick with a hole in it, but I actually don't put the tip here in the fire. Okay, I actually put the butt of the dop stick in the flame, and the reason for that is I don't want to ever get this wax hot with direct heat from the alcohol flame. I want that heat, like I said, we're using the dop stick to our advantage here. That heat is going to go into the dop stick and expand out into the dop stick. Now this also acts like a battery then, much more so than the aluminum dop. What I mean by that is, as I heat this up, it'll retain heat much longer than aluminum. So once I get this warmed up, and I can see here on the end, you can see it's starting to get hot and it's starting to melt. So that means my temperature of the dop stick is good. I'm going to put this in the flame for just a minute. This is just bulk black dop wax. Remember I said, this is still really hot. If I touch this, I burn myself right now. So, but all I'm doing is getting it, you can see, I'm getting it on there nice and good. And less wax, the better, actually. This is not use a ton of wax. Again, I have a timing issue that I need to hit for production, so I don't get a whole lot of time to even just chip off wax and dissolve wax and all that stuff. It has to be pretty quick. So you can see here, I'm going to zoom up so you can see that's how much wax I have on there. It's not a whole lot. I don't have this whole thing just covered in wax. It's just a little bit on the tip and a little bit of residue down the side, but that's okay. So here we go. Now I'm going to show you the technique for dopping a heat-sensitive emerald that's fractured safely, effectively, and very quick. The trick is to just wave it over the flame, nice and gentle like. What that's doing is that's bringing the stone up to temperature very slowly. Heat-sensitive stones is kind of a myth. There are some that really don't like any heat at all, but most of them, it's how fast, it's the shock. So if you just hold it in the flame, sure enough, it's going to explode. Same if you cool it down or throw it in the freezer, which I hear some people doing. Insanity. You don't want to ever shock your stone by having great temperature changes. So nice, you can see I'm just waving this in the flame. It's just warming it up. I'm actually trying to get to 175 degrees, which is kind of relative to the wax and the dop stick. So like I said, this stored a lot of energy still. This is still quite warm. So I'm just going to bring it up to temperature again by the dop stick I'm talking about. I'm just going to bring it up to temperature again. And we're done. I just pop that on there. So I push it down really hard. I'm dopping the table down to the flat dop, pushing it down really hard, making sure that my table is absolutely flat on the dop stick. Now usually I will take this at this point and put it into my quill, and the quill metal will actually absorb the heat out of the dop stick, and make this solidify, the wax solidify. But since I'm not using a quill because I'm not set up to film that and move around, I'm going to use my transfer jig. This is a big chunk of metal here. That's on purpose. They make these really big like that. The bigger, the better. And that's going to take all this heat out of here. So just a few seconds ago, this was too hot for me to even touch with my hands, and now it's just room temperature. Okay, the stone's on there. It's not going to fall off. And that's because this big chunk of metal just absorbed all that heat. So that's what a heat sink is. Now I want to zoom in really close and show you this, how this looks. You see how the wax is sloping up to the outside edge? Okay, that is a good dop. So when the wax is like a ski chute going up to the gemstone, that's actually what you want to see. Sometimes it'll bubble back, and that's kind of hard to explain visually what that looks like, but you'll notice it. If it doesn't look like this, you got to redo it. What happens when it bubbles back like that is you don't have either the stone warm enough or the wax warm enough or the dop stick warm enough. And the trick to all this is to actually keep everything the same temperature. That's why the brass is so important, is it actually stores that energy longer and allows you to maneuver and place your stone really correctly and still get a really good wax seal on there. So this is just as solid now. There's absolutely no flex here. And what I mean by that is if I were to try to, I'm going to show you this. I'm just going to chunk some of this off. Watch, this cracks. It doesn't flex at all. It breaks just like a stone. You see that? That's flaking off of there. It's not gooey. It's not juicy. There's no flex at all. This wax is just as solid as the stone and the brass dop stick. And that's what's really important to me so I can get good accurate cutting. Now, as far as alignment goes, you can actually just, I don't know if you noticed me, but I kind of just pinched it with my 3 fingers and I turned it, and that actually lines up around pretty good. Everything else I just do by eye, but this, you can see that's pretty well centered on there. And again, alignment isn't all that critical, but I will tell you what's really critical at this part. So now, rather than cutting this is usually where I go ahead and cut the pavilion and get the girdle all cleaned up and all that jazz. I'm going to take this off, and I'm going to show you how to transfer it. And I know I just said something that's going to freak you all out. I said I'm going to take this off and transfer it. That's exactly right. Most people like to transfer doing it like this. Actually, let me show you. This is how most people transfer, and it bugs me. They put the stone they want to transfer on the bottom, and they get their other thing over here. This is a cone dop, say, to go, into the pavilion, and they try to get all lined up, and they're, doing this dance, trying to get everything warm, and then the stone shifts, yada yada. What a nightmare. Okay, guys, that's rookie hour. We're going to show you how to do this right. So this is how you transfer a gemstone. And of course, this is my opinion, this is my technique. This has worked for me 100% of the time. It has never failed, and I have had a 100% success rate since I started doing it this way. And here we go. So remember, it's on the crown side. The table is dopped to this. We're gonna transfer this now. You guys ready? Pay attention. Again, like I said, speed for me is a big thing, but accuracy and everything else is also rather important. Now I'm warming up just the brass, never the stone in the flame. It never gets hot. Now watch this. This is how I guarantee that the stone will never ever get hot. I pull it off. See that? There's the stone right there. So this is really hot still. I'm gonna not hold it because I don't want to burn myself. Now I can hold it. So you can see as this warms up, dang, it's still hot. As this warms up, the heat is transferring through the dop stick to the wax. As soon as the wax is loose enough, the stone will just peel off. No pressure at all. There's no chance of me really breaking this stone or anything like that. So now, to cross dop this, all I simply do is clean up the table side of the stone. All I'm doing now is I'm scraping off as much of the wax as possible with my fingernails. Even though it's a fractured stone, even if this was really high polished and everything, I'm never going to scratch it with my fingernail. Especially now that we're all washing our hands, we all have really nice clean hands, so you guarantee you won't scratch it. But you can see I'm just going to try to get as much of that wax off of there as possible. And the reason, again, for that is speed. So there you can see there's still just a little bit on there, but I need to get this all cleaned up. So one of the benefits to doing this transfer this way, this is just alcohol, is that now if I'm cutting within really close tolerances, I can weigh the stone, I can check the dimensions, I can do so much more to it. And actually when I write down everything I do, I actually log in how much I lose on the crown, how much I lose on the pavilion, and how much I lose on just the table. And I can check it in all different spots. Also, when I'm doing lots of recuts, which is what I do most of the time, I can actually check the light performance in the stone at this point. And if I don't like it, I can just dop it back up on the table again and maybe work it again, or add some more facets, or maybe delete some facets, or move culettes over to, optimize color or whatever I'm doing. But this is a way I can check a stone. And some of the really expensive stones, I might literally cut the pavilion 6, 7, 8 times just to get it right. I know I did that on an Alexandrite not too long ago, where I had to get the color balance just right, and so I recut it and recut it and recut it, and you know what? It's just dopping it over and over, checking it, weighing it, making sure all your numbers are adding up. So that's it. So like I said, this is pretty fast. So I literally just had this in here for just a few, maybe a minute, or probably not even that. And now, by scraping off all the wax with my fingernails and throwing it in the alcohol for just a second, which is not toxic to you, you can see now the top of the stone is all nice and clean. So now I'm going to show you how to transfer this. Now, like I said, it was just on this flat dop. We're done with that. Now we're going to go to a cone dop and do the transfer. So now I'm trying to transfer with the table up and the pavilion down. So cone dop, right? You see the cone dop there? Cool, cool. So back into the flame. It's the same exact procedure as what I did before, with one little difference at the end. So the flame, or, there's different heats areas of the flame. It's called the Quantus. I don't know how much you guys want to know about fire, but I actually researched fire quite a bit to understand really what was going on when I was dopping a stone. So, but the Quantus of the flame, or the wavelength of the flame, yada, yada, yada. I'm actually just holding it in the middle if you guys care. I don't know if you do or not. But anyway, so I'm energizing this dop stick now, nice and easy. You're going to start to see the wax on the end again. It's coming off. So that way I know I am warm enough. This in the fire for just a little bit. And there you go. Now you don't ever want to get your wax on fire, and you really don't want it to get it to smoke. It just smoked there for just a second. And the reason for that is that actually makes carbon. And carbon will inhibit the adhesiveness of the wax. So that is why you don't ever want to really get the wax into the fire, except to just load your dop. So here we go, back again in the flame. Da, 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 da. Neat, easy, done. I just popped that on there. Done with the fire. Now, here comes the fun part. This is cross dopping, okay? So now I'm table up. I stick it in here, my transfer jig. I have a big target dop. I want to show you guys really exactly what's happening here. If I can zoom in. There we go. Watch what happens. Do, 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 do. Oh, you see that? Perfect. Now I'm done. That's how hard it is to transfer a stone. Now what's going on here is actually pretty interesting. This was really hot before, like I said, the brass. So it started to get absorbed by this. So this started to cool down by the big chunk of metal of the transfer jig. Now this is a target dop. It's big, it's flat, and it's aluminum. That's really important. The reason for that is that's going to suck all the heat this way away from the stone. Like I said, this transfers much more heat quickly than the brass. So that's going to cool the stone down and get it right in line with where you want. Now the reason it's big and flat is because I wanted that table to be absolutely perpendicular to this brass dop. And that's how you get a really good perpendicular alignment there. So now everything's done. This is all cool, I can guarantee it. And there you go. Transfer done. Now I know some of you might be wondering, like, how do you line it, like up, down, left, right, all that jazz. Well, it doesn't really matter, and I'll tell you why. This is just basic gemstone cutting 101, but light enters the table, right? It enters the table, and then it goes down into the pavilion, it bounces around, or it does whatever you want it to do. If it goes through the stone or out the side of the stone or back up, ideally, that's what happens, and it comes back out through the table. So guess what? It doesn't really matter whether you're lining up your girdles. If you're a competition cutter and you're cutting a diagram, that might matter a little bit, I suppose. But you know what? I've done plenty of stones like that, and I've done it this way without any issues at all. So, but really, the alignment that you guys are thinking of is not crown to pavilion accuracy, which that's actually easy to do with just a little bit of cheating and figuring out where everything is. Alignment really in the stone is only the table versus the girdle versus the pavilion. That's all that matters. Those are the functioning parts of a gemstone. So there you go, transfer done. So that's how I do it. This in reality takes me about a minute to do any gemstone. Bigger stones actually take a little bit longer, and smaller stones actually take less time because there's less material to warm up. So, but I use the same exact technique and the same tools for literally every gemstone I do. I can do, Mexican fire opal this way. I can do rhodochrosite this way, kyanite this way. A lot of stones that you would probably not ideally want to dop with heat. It's actually, remember, it's heat over time. Thermal shock, that's what we're avoiding. So there you go, a super long video explaining all the science behind this stuff. It does take some practice. It is a technique, and just sit around and practice it a few times. You'll start to see how things go. Hopefully you enjoy it. If you have any problems with it, message me and I'll do my best to explain it to you further. Have a good day.